So good afternoon, everybody. I'm Zsolt. I have a funny name. I'm Hungarian, but don't worry, I don't live in London, so not another Hungarian in the city. And so if you would like to talk to me, here's my Twitter account. You can find me on Twitter or use the hashtag of the conference, whatever one you like. And I'm working with teams. I'm actually not a consultant, and I'm not working for Linkit. I just like this T-shirt because it says praise the board. You can interpret it any way you like. So let's start. Let me start with a quick story. So this is a map of Budapest. It's nothing interesting about it. But what I do is I live somewhere here, and I have to get to work somewhere at this part of the city. And I wanted to see how far can I do it on a bicycle. So I ride a bicycle because it's cheaper and it's fun. And these are the lead times, moving and waiting and flow efficiency I had to do. So this means that there was a time when I was waiting in traffic for 12 minutes, when I had to wait for 4 minutes. And what I planned here is to prove that if I aim for a better flow efficiency, I can get to work faster, because David likes to talk about flow efficiency, and I thought, no, let's prove that he's wrong, and unfortunately I failed to do it. But here I learned something interesting, that if you really put an effort into cycling to work, maybe you get there faster, but nobody will sit next to you because of the sweating and the interesting smell you produce. So I not really advise you to do faster to the work, so take your time. But you can ask the question, where is the Kanban method in all this? So that's actually a very fair question, and it's in the deltas between the steps. So it's not about getting to work faster, but to improve continuously. So I have two important messages to you, and then you can leave and your time was well spent. Then the first one is the small incremental changes. So we are talking about, then I would like to reach a later state, and the plan is to get there step by step and not by a big jump. And the other one is the pull system. So people talked about pull system before me, so that's a lucky thing, so I don't have to repeat what they said. But if you compare a pull system with a push system, where a push is that I did what I planned, and I pushed the work on somebody else, and then I have the pull system that, okay, I need some work from somebody else. If you just think about these two ideas, that if you aiming for a better workplace or a better world, let's make it a big goal, then you cannot actually improve a push system because it's very individualistic. So there is no way that you can convince one person not to push. But if you actually implement a pull system, you have a chance to improve and collaborate with the others. So because if I'm pushing, I don't care about the others. When I'm pulling, there is at least somebody else in a party. And my message here is, if you get the message about the pull system and the small incremental changes, you are fine, because you can deduce the rest, what's in the Kanban method. But let me continue with my deduction. But if you take these two ideas, then I believe you are going to be fine. So if I cannot see something, it's really hard to improve, because it lives in my imagination, but that's a very nice place. For somebody else, it's a very dark place. But if you just imagine certain things, it's very hard to improve. You have to make it visible, or you must make it visible. So I have a sample team, these three guys. I'm going to use them in the presentation. They are not actually from South Park, but they could be. So the one idea is start where you are at the moment. So it's like an end-to-end, so figure out what are you doing now, and start from that one. And one tactic or one method you can use is a value stream mapping. It has a very fancy name, because everything comes from Toyota and Japan. It's fancy, but I don't know the Japanese term for that one. But it actually means that you try to draw or collect what's going on in the environment you are in at the moment. What you can see here is there is a design phase, there's some implementation, there is some testing and delivery. And what you can additionally see, what Jim Benson was talking about, how the information flows. So if you look at this picture and you ask yourself a question, how the hell do the designers know how their work has been used? Can you answer this question? So they don't really know, because there is no information arrow back to design. So if you do value stream mapping like this, you can easily figure out, okay, these guys just doing stuff, and they don't really tell them, okay, what you are doing is actually useful to us or don't. So moving forward with this idea, just remove the slack. You can draw your vertical lines over each phase, and you have a very nice Kanban board. So actually, the process comes first, and then the board, and not the other way around. But it's easier to draw a board and adapt your process to it. But if you'd like to achieve something, you need the process first. And you can help you with the questions like, am I pooling or am I improving? So if I just drawing a picture, I'm not really doing anything, I'm not really pooling, so the questions don't really work here. But the changes must have a good basis. And the basis is, like I said, is a reality. So the previous board was a traditional one, and how about a less traditional one? So this is a board I used with a couple of my friends, because we were arguing about 1 or 2 days whether we have the value stream properly or don't, and we ended up with this. So it looks like a gaming board, but it has all the features that a usual Kanban board should have. Why? Because we have the limits, we have the phases, we have the cards, we improved it, that's version 2. So it has all the features, but what's actually going on here, we weren't sure what's happening in the middle of our work. So we did something here, and magically, work appears in this column, and then it appears here, and eventually it gets out of the system. But if you observe this image carefully, you can see that we have research not connected to anything. So it seems that somebody is doing research for nothing. It wasn't really visible before that. And we still have several other tasks just for nothing. So actually, this picture helped us figuring out that we have a huge problem here. And eventually, it turned out that the product manager was moving the cards here. But before that, it wasn't really visible. He was the one who authorized the design and let it go to implementation. Okay. So, like I said, we wanted to see how it works. But usually, the flow looks like this, or the value stream. I'm going to call it flow. So it starts at the left and ends at the right. But if you are working with an enterprise company or with a startup, there is a trick. The flow looks differently in those two. Because this is how the flow looks like for an enterprise organization. We can call them large companies or whatever, that they actually, the flow goes through the different teams. So this can be an architect team, an implementation team, and design team. And where they have the problems is between the teams. If you look at a startup architecture, they have several flows. So they are working on a product, not on projects mostly, and they have the flow parallel, but actually it's the same flow. And if you like, or at least if I'm trying to improve what they are doing with a traditional idea that, okay, now I know how to work with enterprise companies, I'm going to fail. Because they don't have problems when the flow, let's say the subflows connect, but when they actually meet at the end. So this team is working on something, this is another thing, and the decision is whether this work should go to the production or this one. Actually, that's the question. And not figuring out why the work from the testing department piles up after the testing department or before the development department. So now we can see what we were unable to see before. So let's improve the system. So now comes the small changes thinking here. So here is the board with the 5 cards. And how many pulls shall I do to finish at least one item on this board? Then, say 5, please. 5, yeah, thanks. So here is 1, 2, 3, 4, 5. So actually there were 5 pulls. Everything is fine, but still nothing here. So what shall we do to make it work? So let's see, the answer is quite easy, that the pull system itself doesn't guarantee that work gets done, but we need the WIP limit, or a work in progress limitation, just to see how it works. And adding the limits, now this work item is here in this column, and this cannot be pulled until this leaves the system. So even in this setup, it's possible that nothing gets delivered in 5 steps, but it's more likely than in the previous state. And here's a very important message, that we have a portfolio Kanban, personal Kanban, the Kanban method, and they use the WIP in very, very differently. So in a personal Kanban, we use the WIP limit to reduce context switching or making one person focusing on one item. In the Kanban method, we use the WIP limits to move the work items further to get something delivered. It doesn't mean that it's against context switching, but the main purpose is different. So it's a very important detail I wanted to mention. So the best question is how to set the WIP limit at the beginning. I love the random numbers, but I was alone with this approach. But eventually somebody else came up with some better ideas that we can have a staff liquidity, let's say workshop or table, that this idea comes from Chris Metz and Olaf Malson, that let's see who is capable of working in this column. Let's say rate them between 1 and then 3, and make the number for the work items according to this. So what you can see here is this guy is very capable working on this item. He needs help. He has no idea what he's doing. So that's one part. The other is, okay, how many items can we queue up here? So it's still a bit random, but maybe you see that the upcoming column or upcoming phrase is a bit more slower or faster. You will need some queuing, but actually with these 2 numbers, you can have a good start. But keep in mind that if you set a too high or a too low WIP limit, that's actually painful. So if you set a too high, you can pull too many items there and the work won't leave the system. And if it's too low, it will prevent actually moving things forward. So unfortunately, you need a kind of ideal work in progress limit. But luckily, this can change over time and you can observe the change. So this means that in week 1, we had this kind of WIP, next week this one, and then this one. And using this diagram, mind that the figures has changed, you can come up with a better number. So you can actually observe how the WIP changes in a certain column and make a better Kanban system of yours. So it's time that we talk about a couple of myths. And the first one is the inventory. So I'm going to read up to you something from the Toyota production book. I usually carry the book with me, but it was too heavy this time, so I'm just going to read up what's upstairs. So that's the Taichi Ono who wrote this in the book, that too many workers, equipment, and product only increase the cost and cause secondary waste. It's a usual thing. Waste, for example, with too many workers, unnecessary work is invented, which in turn increases power and material usage. This is secondary waste. The greatest waste of all is excess inventory. If there is too much inventory for the plant to store, you must build a warehouse, hire workers to carry the goods to this warehouse, and probably buy a carrying cart for each worker. And he goes on. So the message here is, I would say it's quite obvious, but you have to think about this. So what's the only thing they don't have at a factory? What's actually limited at a factory? The space. So what the problem they had, it's not because Japan is an island. So certain colleagues thought that, okay, that's why they are limiting stuff, because they are on an island. Most probably I'm not working with the most or the brightest guys, but actually they don't have space. So when they improve their system or work with their lean implementation, or it depends how you would like to call it, it's because they don't have space where to put the parts. So if you imagine a car factory, they aren't producing waste as wrong parts or wrong cars or stuff like that. So what they use in their value stream is actually working. They don't really have space where to put the working parts. On the other hand, in the software industry, we have unlimited space. So when the GitHub runs out of space, then we can close everything down and go on holiday. But it won't really happen in the near future. But what we do is do some stuff that's not actually the thing we're supposed to do. So the message here is that if you take something out of the context, like the inventory handling, you're probably going to do more damage than you are about to do some good thinking or good stuff. So if you take something out of the mobile industry context, think about it twice. What was the intention and why the guys did it in the first place, and move it to your context. So that was the storytelling. That's just a repetition. And before talking the inventory is kind of a queue, and there are other interesting kind of queues, and luckily our sleepy Jabe is back. He was talking about the infinite queues. So infinite queues connect different systems, but the trick with them is either they are visible or invisible. And why it's a problem? It's not necessarily a problem. Until we have infinite queues, we are going to have work, but that's a good thing. But the work is going to pile up here. That's something we can do about. We can do about it here and here as well. But it's really hard to see what's going on. And it goes back to the previous statement that how can you improve something that you don't really see? So now we're getting things delivered, and let's say, how can we do it faster? So here's a diagram about the lead times. I like lead times. And what does it say? That the lead time actually starts when the commitment is made, despite the rumors or former misconception that the lead time starts when we actually start working on something, and ends when it's out of the system. And why it's important? This small thing can take weeks, months, or years. And most of the problem I saw during my career came from that small part, because developers thought that the promise or the commitment starts when they actually started working on the thing. Management thought, okay, it started when I had the idea. And just as an example, I was working in a larger organization, and we had a lead time of 17 months for a product. And we checked, and we needed 2 weeks to finish it. And actually, that 16.5 months was here. We were happy that we finished something complicated in 2 weeks, but the management wasn't happy that it never actually left the system in that year when we were working on it. Here's the distribution of lead times. Troy will talk more about this, but I would like to talk more about the difference between an average, median, and how we can use this diagram. So if we are working with average, let's say I make a commitment based on an average. This is actual data, but with this team we say, okay, in average we need 8 days to finish the work, and we make a commitment. We have proofs from the past that there were cases when we actually needed more time than 8 days. So if we make a commitment, there is very likely in this case that we won't fulfill it in the future. So the saying is that you pick a range at 85% in this case, and you commit to that time. So if you are finished earlier, that's actually not a bad thing, because then you have some slack, you can use it for improvement or do something else. But if you are later, that's actually very problematic. There is another time called tech time. I won't spend too much time on it, but here the point is that there is a quantitative demand. So if you imagine a car manufacturing, they have to deliver a certain amount of cars in a certain amount of time interval. But in the software industry, we don't really do that. So actually knowing that how much time we spend between features has low information to us. So focus on those things that actually can help us moving forward. And when I was mentioning quantitative demand, or it was actually on the slide, I was talking about more likely the throughput. The throughput is that if we can deliver a certain amount of work in a certain amount of time, that's actually a very good idea in the manufacturing. But in the software industry, we are usually not supposed to deliver 10 features. We should deliver the feature. And we have the product. So usually that's a singular. So we can say that all throughput should be always 1, but there is something that differs from in manufacturing and software industry. But we can use throughput to see whether we are good at what we are doing, and it can actually help us improving our system. So here's an actual diagram of throughput, and it's helpful when you see a throughput as an outcome. in contrast with the income. So if you see it, week 1, this team get a bit more work than finished, and actually they are getting more and more work than they are actually be able to do. But using the throughput, you can actually make the team a bit more stable. So if you know that you cannot finish more than 6 items a week, why do you force yourself to make it 7 or 8? So you can simply say that in this phase, there is no way that we are going to work more than 6 items. And if you summarize these numbers, they shouldn't be exactly the same as it calls WIP number. So the goal is to have a stable system, because it's easier to improve a stable system than an unstable one. So it's like if I'm about to build a stack from tables, it's easier to build from very stable tables than actually stuff like that move around. So let's say it's week 5, and here we have this nice item, and it's called the aging item. So if you look at the throughput diagram, that now it's getting stable, and team is getting better and better. That's actually very nice, but if you're about to forecast, the aging items can mess your forecasting up, and it's very important. And why? Because here we can say that we can deliver 9 items in a week, we get 9 items in a week, we can deliver n items in a week, so therefore we can deliver an item in a week. That's a nice conclusion. If we move it forward, we deliver an item in a week, therefore our lead time is the length of the week, which is 5 days. So if you studied philosophy, that's a very, very weak conclusion, and if you read it up, a decent philosopher stops thinking about philosophy and pick another profession, or a kitten will die. But actually that's very weak stuff. And it's because of the aging items. And with the histogram, you can actually see them. So here are all the 5s and before the 5, but you actually have something else. And 5 does not equal the range of 6 till 9. So keep an eye on the aging items. So, and the last thing I wanted to talk about today is we usually use the WIP limit to protect the bottleneck. And unfortunately, it doesn't really protect the bottleneck, but hurts the system. So imagine that this phase is the bottleneck here. Usually we put testing there, but let's put DevOps there just to make it more interesting. So we say DevOps is a bottleneck. And we punish them with a lower WIP because they cannot really produce more. Here's your punishment, a lower WIP limit. But if you punish them with a 2, the work will pile up here, and that's going to hurt the previous system. And that's very important because your intentions are good. You would like to protect something, but actually you are ruining something else. And the better approach is to figure out how to distribute the pain in the previous part of the system. So you say here, so if only 2 items can pass through this, why produce more in the beginning? Let's figure out how to provide enough that they will survive. And then when it's stable and this limit can be increased to 3, you can remove this limit and continue working and see how the system reacts. So to close the talk, again, if you think about how to implement a system that evolutionarily changes, and you would like to do pooling, so you always ask your question, am I improving or am I pooling? And if you cannot answer at least one of the questions with yes, you aren't doing something properly according to the Kanban method. So, but if you have yes to both of the questions and you get stuck, like I said, you can easily deduce the rest and then move forward. And the +1, don't just take stuff from the car manufacturing because it's easy to pick from there, but actually that's a completely different context. And that can hurt you either in a midterm or a long term. So that was all. We're still in time. Thank you very much for being here. You were great, guys. I appreciate it. Nice to see you. And now it's a coffee break. I'm keeping you from that one, so there won't be no 10-second silence for questions. So this is how I look. This is how I sound. You can find me later during the conference. There isn't too much time. And there was a Twitter ID and my website. And keep us questions. I try to answer them nicely. So thank you again, and see you later.